35 billion parameters, 24 gigabytes of RAM. This should be impossible, but watch the memory. I'm going to show you whether it actually fits, and the receipts that prove it. This should not run, or at least it should not run without a very specific set of receipts. This Mac has one shared memory pool. macOS takes from it, apps take from it, the runtime takes from it, the model weights and key value cache take from it. There is no second pile of graphics memory waiting off camera. One budget, one question: can this configuration survive inside it? The candidate is on screen. I will call it this model. Its card says 35 billion parameters in total. About 3 billion are active for each token. The selected 3-bit weight shards total 15.2 gigabytes on disk. That number sounds encouraging. It is also the first trap. 15.2 gigabytes is the cost of the file. It is not the cost of the run. Before anything answers, this machine has to pay for macOS, the runtime, open apps, and the conversation itself. So, the budget starts at 24, subtract the operating system, subtract the live runtime, subtract the weights. What remains is not comfort. It is the space where the key value cache has to work. 3-bit quantization is why this test is even on the table. It packs the weights more aggressively. That makes the artifact smaller and can reduce memory traffic. It can also lose useful detail. Smaller is not automatically good. It is a trade that has to earn its result on a real task. Then comes the misleading number. About 3 billion active parameters does not mean this is a 3 billion parameter memory bill. This is a mixture of experts model. For each token, a router calls a few specialist paths. That can reduce compute. It does not make the rest of the stored model disappear. Compute is not storage. Now watch the cache in normal use. This is not a benchmark, it is the status panel, while this model is generating on this Mac. Prefill moves from about 5,300 tokens to about 9,300. The runtime cache grows from 1.2 to 1.3 gigabytes. The system uses 23.3 of its 25.8 gigabytes while generating. It settles lower when idle. Graphics wired memory rises to 17.5 gigabytes from 15.6 at idle. The point is not a magic context limit. The server has a 33,000 token context setting. This is a live reminder that the cache grows as you use it. On a 24 gigabyte machine, you can watch the headroom disappear in real time. At this point, the file is downloaded, the budget is tight, the cache has taken another bite, and we still hold the answer. That card proves the artifact exists. It proves nothing about the outcome. Loopback means this machine, not a cloud endpoint with a mustache. There it is. This exact 3-bit artifact answered on this exact M4 Pro. The file fit. The live system had room to generate. That is a result for this configuration at this moment. Change the artifact, context, runtime, open apps, or concurrency, and the budget changes too. Then a real coding agent uses the local model on this Mac. It reads its own documentation and proposes package update commands. It does not take the action. It asks, would you like me to run the update for you? That is the useful boundary. The agent proposes, the human decides. Then Wi-Fi goes off. I rerun the same downloaded model. If that captured rerun completes with no egress, it is an offline receipt for this bounded test. Local inference, local endpoint, local data. It is not a privacy certificate for every app on the Mac. That is the rule. Inspect the exact file, budget for the runtime and cache, watch the cache grow in normal use, keep the endpoint on loopback. The receipts tell us where this configuration held. That is better than a parameter count. Subscribe for the next measured build. I will bring the logs.